All right, let's continue on with 10.7. So now that we've introduced what parametric equations are, let's go ahead and try to graph them. So example 1, write the corresponding rectangular equation by eliminating the parameter. It's kind of weird. We just talked about how you introduce one, so now we're going to get rid of it. Then you're going to sketch the curve represented by the equations and then also indicate the orientation. So what direction would you walk if you were going to walk along the curve? So a lot of times when you go to graph these things, it's easier if you convert the parametric equation back into rectangular form, because this is a little bit tricky to kind of wrap your head around. You're like, whoa, what's that going to look like? So what I would usually do is I would take this x equation and I would solve it for t. So just move the 3 over and add it to the x. And then now that you know what t equals, you're going to plug it into the y equation. And that's how you eliminate the parameter. You're trying to get rid of this t and get everything in terms of just y and x together into one equation. So let's go ahead and distribute the 2 and combine like terms. So y is equal to 2x plus 10. So this we can graph. This is, we know what this is. That's just going to be a line with a slope of 2 and a y-intercept at 10. So just like that. The x-intercept would actually be -5. Okay, so there's your curve. Now you just need to know the orientation. So are you going to be walking this way or like up and to the right, or are we working our way down and to the left? So what you can do, and most of the time you just can sort of think about it. It's not really all that hard to do. You can go back to your x equation or the y, either one. I usually go with the x. And just think about it. If you started to plug in larger and larger and larger values for t, what's going to happen with x? Is it going to also get larger and larger, or is it going to get smaller and smaller? And so if you're still not sure, if you're just like, oh, I can't tell, then make a little chart. Like plug in 0 for t and get an answer for x. Then plug in 1, 2. You can plug in more values if you need it, if you can't tell after that. So 3, 4, 5, 6. Plug them in for t and see what you get. So if t is equal to 1, you get -2. If t is equal to 2, you get -1. And then just for fun, let's plug in like 8. So if t is equal to 8, x is 5. So look at your x values. What are they doing? T is getting bigger, and your x values are also getting bigger. So as time marches on, your x values are going in this direction off to the right. So put an arrow on your curve to signify that yes, you are moving to the right. You're also moving up, but you're also moving right. So your orientation is going to be going in 2 different directions. One involving up and down, the other one left and right. Okay, let's go ahead and try this next one. So again, I'm going to take this equation and I'm going to solve it for t. So I've got to square both sides, and then I'm going to divide by 2, and there's my t. So now I can plug it in to the y. And y is going to equal 2x squared. And we know what that looks like as well. A bit more straightforward than just trying to go off of the 2 equations. So y equals 2x squared. That is a parabola that opens up, but we have a restricted time value. t has to be greater than or equal to 0. And that's something that they gave us, but why is this here? Well, most of the time when they give you a restriction like this, it's because it's being affected by the domain of one or both of those equations. So this right here is trying to get you to realize that, hey, that's really kind of the domain of this. I can't plug in negative t's because then you'd have a negative inside of the radical. So when they give you this, it's really because of some function in there. It's not that they're trying to be mean or anything. So if your t is going to be greater than 0, greater than or equal to, that means the y values are also 0 or positive, just because you can only plug in 0 or positives for t. And if you multiply them by 4, it's still 0 or a positive. Now the x's, they naturally come out as 0 or positive as well, because they're square roots. And those are the only numbers that come out of a square root. So because of that restriction, we know x is greater than or equal to 0, and we know y is greater than or equal to 0. So we can't draw the whole parabola, because then you'd have things over here on the negative x's. So we can only draw that right half. Okay, so now you can get your orientation as well. So as t gets larger and larger, x also gets larger and larger. So things are working their way to the right. All right, let's go ahead and stop this video here, and then we'll try some other examples, and then maybe hit some application.